हेलो। हाँ बस हम ही फोन किए थे कि विपिन का कार चेंज लेवा दीजिए। ओके।
9:53, and we started our clock at 10:23 in the morning. Since that time, we've been working really hard. We got the vehicles powered up and have been doing testing throughout the day and evening as we worked along. We did yesterday, you may have seen, we had some, how we call them, kind of spectacular, amazing events as we do every day here in Florida. Some lightning things happen. We'll go ahead and I want to mention that up front. We did have some strikes that we recorded on our tower, lightning tower to pad, working as it normally should. And we did have those. We've been evaluating those through yesterday and through last night. And with everything to date, it looks very good from a vehicle perspective. We haven't had to do any significant retest. We have a threshold that we look at to see what the magnitude of these strikes are, and we did not meet that criteria to have to do intensive or invasive type of retest. So we're able to work all of that yesterday very cleanly with our team, and our management team did approve last night that as well. Those occurred yesterday afternoon at about 1:14 or so in the afternoon. We had a couple events at 1:16. So far everything looks really good, and as I mentioned, we have gone through and worked all of the evaluations that are normally done when we do have these type of lightning events. And hopefully we won't have any today, but we understand the weather. We'll be talking about that here next, and we'll see what that's gonna bring us. We did do a little bit of retest, which included, we did some canary circuit checks, which are really just, those circuits are there to provide, if they've seen any type of voltage or things like that might affect the vehicles. Those were all good. We did some walk downs, and then we did the analysis with our system experts as far as all the data and what those lightning events were. So bottom line is we look really good. No issues, no concerns or constraints from the lightning events at this point. Let's see. So far, I did mention we powered up yesterday. Later in the afternoon or last night, we did power up the RF systems on all of the vehicles, on Orion, on the core stage, on ICPS. Did those checkouts and tests. Those all went really well. We finished those into the early hours of the morning this morning. We did also work our engine final preps on the core stage yesterday. Got through all of those, and again, those finished early this morning as well, about 1 o'clock in the morning. We've done the battery charging on both Orion and the core stage. Those are complete. So that's all going really well and all as planned and on schedule. We are currently pressurizing our helium tanks on the core stage and configuring some of the umbilicals. We've looked ahead at the weather. We know we're going to probably get some later this afternoon. We did have quite a bit of work planned on second shift tonight. We're pulling some of that in to try to get those events going on some of the pad facility closeouts and some of the configurations that we do on some of the water systems and elevators and some of those other things. So we are trying to be very proactive, looking ahead and evaluating those things and adjusting as required, knowing that we might get some weather as we have the last few days. Let's see. We are going to continue later today with some of the Orion checkouts and some of the health checks that we do on those. Those are just standard and normal that we do. As we get into this tonight, we will be working towards cryo load. And the first part of that is getting on GN2 and inerting the vehicle. We're working those preps later second shift tonight. At about 9:45 or so, we'll be flowing GN2 to the vehicle to inert it to get ready for cryo load later when we get back in after we get done with that. Sorry. We will clear the pad at about 8:30 tonight, just in anticipation of the safe and armament device organizations that we do, which are normal planned things that we do before we get into cryo load. And that'll happen at about 10:30, and then we'll enter our 2.5 hour built-in hold at 10:53 tonight. I think we've talked a few times that we did extend that quite a while back from where it was previously, but it's 2.5 hours starting then. Towards the end of that hole at 11:53 tonight, we're expecting to get a go from the launch director and MMT if everything looks good and they've evaluated all the criteria, and we are going to be go for cryo load. That's the timing that we would be looking for to get that, and then we would start the cryo load operations at that time with some of our configurations getting ready to flow cryos. We start on the liquid oxygen side, and then a little bit later, about an hour and a half or so, we start on the hydrogen side on the core stage and work through that. Once the core stage is done, then we fill the upper stage as well throughout the night. We do have the pre-press test scheduled for about 5:40 a.m. That test shouldn't take us too long. I think it's been talked a couple of times, but it's a test that actually is we do during the terminal part account, and we're just going to do it a little bit early just to get some evaluate the data there and the performance of the valve, the valving as well, so we can kind of pre-select the positions of some of those valves as we get into terminal count. So that'll help us out a little bit there. We have some final guidance system aligns that we'll be working as we're doing tanking as well. We power up the range safety systems to do some final checkouts about 2 hours or so prior to launch. We'll work all through those as per our normal timelines. We do also have some of our final vehicle and ground configs that we'll do once we get to the hold. There's a hold at T-minus 10 minutes. It's 30 minutes long. That picks up at about 7:53. We do anticipate the opening of the window and hitting that at 8:33 a.m. We have a 2-hour window on our first day. If for some reason we do have to use subsequent days, our nominal plan is to go on the 5th. The opening of that window is at 12:48 local time. And, the second is the first opportunity, sorry. It's 4-day turnaround, and then the next opportunity will be on the 5th at 17:12, which is 5:12 in the afternoon. So that's kind of where we are. It's been a really good first day of the launch countdown. We're within 24 hours of launch right now, which is pretty amazing for where we've been on this journey. So our team right now is, I will say, super excited, and we are prepared for anything I think that throws at us. The 4 WDRs we've done in the past really, I think, have prepared us for the moment we're at now for virtually any situation that can come up. But we are excited. The vehicle's going to be ready. It's ready right now. Looks great to proceed with this inaugural launch of the Artemis program. Thank you.
Thank you. Sounds like we're in a good spot. Thank you for that update. All right, Melody, how's the weather?
Well, the weather's pretty decent this morning, but of course I will talk about the forecast for launch a little bit later. First, I'm going to talk about today. So let's go ahead and toss it off to the satellite imagery. And as we look at satellite this morning, you can see some remnant showers and a leftover thunderstorm or two from last night's activity that rolled through late in the day. Also, as we creep forward in time, as we get to around 10 or 11 o'clock this morning, just like yesterday, we'll start to see some of those showers and possible thunderstorms forming along the East Coast. Something different has changed today, which we were expecting. We do have southeasterly flow in place this morning, and that will remain the case for tomorrow morning's launch attempt as well. So one thing that will benefit us today is, even though we're likely going to get rain, just like we almost always do in the Space Coast in August and September, the East Coast sea breeze will creep farther across the interior central portion of the state, and hopefully will give us a large block of time of clearing this afternoon. We may be examining the chance for some late night showers and maybe a thunderstorm or two somewhere across interior Florida, but most of the convective activity should be done for when we're looking to tank later on tonight. And with that, we'll go ahead and move on to the launch forecast for tomorrow morning. It's a pretty similar outlook from what I had yesterday, but I'm kind of slicing and dicing it for you. Basically, the beginning of the launch window, or just after 8:30 in the morning, has a 80% chance of favorable weather. As we creep forward in time through the 2-hour launch window, we just have a better chance of some of those offshore showers and maybe a thunderstorm or two creeping closer to the coastline. And also because across the spaceport, we're likely to have some billowing clouds form as we get into 10 o'clock and the 11 o'clock time frame in the late morning hours. So as usual, or just like yesterday, I do not have a backup forecast for you because that is a 5-day forecast now. I will have those estimates for you tomorrow if they are needed for the backup launch window. The one thing to note, though, is the forecast is largely going to depend on the evolution of the tropics, and also the time of day is going to be a contributing factor. The time of day for the backup launch window is around noon to 2 p.m.-ish time frame, when in general you can expect a higher probability of violation for weather just because we're likely to have those showers and storms forming along the coastline during that time frame. So with that, I think that concludes my brief. I'll toss it back.
Thank you so much. Thanks for that refined look at the launch window. So we'll take questions now. You know the drill in the room. Raise your hands and we'll try to get a mic to you. And then we also have some people on the phone. Hit *1 to get yourself into the question queue. Okay, so we'll start with Marsha over there.
Marsha Dunn, AP for Jeff. So there was no residual effects impact to even any of the ground equipment from the lightning strikes. And when you first saw the video or pictures of that, like, were you also worried that, you know, this is it, there goes our try? And lastly, brand new rocket. What's your take on whether it's really going to take off tomorrow? Whether on, you know, aside.
All right, a lot of questions. So we have tested a lot of, including our ground systems. We went back and looked at those, and we also walked them down as we do when there are lightning strikes and we get to certain levels, just to make sure there's nothing beyond what we can see via the data that we may have missed. And so that's what we have done. And the systems went out and did that yesterday during the day as well. On top of that, we haven't seen anything on the ground systems that gives us any concern, nor on any of the vehicle as well. I would say whenever we see things that are as dramatic as lightning, right, we pay a lot of attention to it, as we should. And so that just for us kicks us off into the next mode for us to go and evaluate what happened. I'd say we've seen it enough through the processing flows that we just do, and are, not that we're comfortable with it, but that we are definitely well rehearsed at the process by which we go and collect the data, look at the data, see what we need to do from a vehicle and ground system perspective, and then move on from there, and then evaluate whether we have to do more after we've done all of those initial data collects. And that's where we got to yesterday and got through all the initial parts, and then we looked good at that point. So, and I would say my thoughts are that we look great for tomorrow. Love the fact that the weather looks really like it's going to cooperate at the beginning of the window, and our job is to get to the beginning of the window, and that's what I'm going to try to get the team to do.
Thank you. Irene.
Irene Fox with Aviation Week. Yesterday we were briefed about some communications reconfigurations that needed to be retested in Orion. What was the status of that, and what was changed, and why was it changed?
There were a couple of different parameters that when our JSC flight control team, when we do our comm checkouts and those types of things, they have a command window in which they upload parameters that we need for guidance and a whole lot of other things that during that time frame. There were a couple of items that we saw late on the comm system that needed to be changed, and that this goes in as part of that upload to the vehicle that occurred. And so I would say it's in the normal process for us to be able to do that, and that's what they were able to do as well. We can probably get some more specific data about the data parameters themselves if you need that. But what we can say is that we did complete that part of it, and right now everything looks good. There's no issues with that right now.
No, I meant in general, beyond the comms checks.
The only thing that we're looking at this morning is, and we're not even out of spec, is on our helium provider that's at the CCF. Last night, the helium supply pressures were a little bit low, so they have a vendor coming out to look at that. They think they may have a small leak. Again, it's within the band that we need to support us for launch, but they want to make sure that we're in the best configuration we can be for that system, since we do use a fair amount of helium on this rocket. And so that's one of the things we're looking at this morning to see if there's something that needs to be done. And those folks will be should be on station now.
Over there.
Good morning, Tom Costello with NBC News. Two quick questions. Jeff, I heard you say a few, and then I counted, was it 2 lightning strikes or more than 2 that you had on the...
Were evaluated that got to the threshold that we needed to go and look at and evaluate them. They happen in fairly rapid succession sometimes, these events that occur. And when the events are, we have monitoring devices at the pad, on the ML and the pad itself that collect data, and then we go back and evaluate those data. There was 5 of those items that we looked at to evaluate whether it was going to be a concern for the vehicle as far as the magnitude or anything else to that effect. And that only got us to the criteria to go and take a look at the systems that we did, and it was not at such a magnitude that we needed to go and do anything beyond that. It was well within or had not even come close to the exceedance of what those requirements were.
Two more very quick ones. Number one, do you anticipate that the helium, the tiny, small helium leak could become a showstopper? That's number one. Number two, you cannot, am I correct that you don't tolerate rain at all for a launch? You would not launch with rain at all. Is that correct?
So there is a fly-through rain constraint. Melody could probably speak to it better than I, since they're responsible for those LCCs as well. And I'll let her answer when I'm done. And then the first one was on the helium. Right now, again, we're within tolerance on being able to support us for launch. This would be to get us even more tolerance on that as well. So we're looking at it. I don't expect it to be, if anything, they might go in and retorque a flange or something like that. I don't, but beyond that, no idea if we're going to have to do anything else.
One question here, and then we'll go to Bill.
So, I'm Rebecca Morell from BBC News. A few quick questions. The first is, how many seconds before launch do the 4 RS-25 engines ignite? For the shuttle, it's about 5 or 6 seconds before.
Yeah. Sorry. Go ahead. Several questions.
Just the second one, it's down to the seconds again, actually. If you do go at the start of the launch window, are you aiming for 8:33 exactly, or would it be like 8:33 and 15 seconds or 40 seconds, or, just how exact is that number if it goes there?
Yeah, those are great questions. So the engines start, and it's a staggered start on the engines, about every 200 milliseconds in between the start times on the engines. But it's about 6.8 seconds when we'll be starting the engines up. And then the timing for the opening of the window and our T0 time that we'll be shooting for in the beginning is exactly at 8:33:00.
Okay, Bill.
First of all, if you were going to say something about the weather constraint, or
For the fly-through constraint, that is true. There is a constraint we can't fly through, something we consider precipitation, which, if you're a meteorologist, we consider that 18 dBz on the radar. The thing about it, though, is we have to be flying directly through it. There's not really a standoff distance for that. So because of that, it does buy us a decent amount of real estate on the radar as far as finding the hole in the clouds for us to launch through. And also, a lot of times, it has to be right over the pad, because when we launch and we go up, right? And we oftentimes fly over these low clouds that have rain. So hopefully that answers your question.
Bottom line is, it's not 100%. It's now a little rain.
You can't fly through anything. Correct. Yes.
Bill Harvey, CBS News. Jeff, two quick ones from me. For the record, the helium is on the ground side, I'm assuming.
Yes.
It's not in the COP.
It's on the supply side, on the facility side.
Yeah. You've done a lot of shuttle countdowns back in the day, and this is a very similar countdown from shuttle, except the quantities are different, things like that. What are the 2 or 3 things you're looking forward to? And I won't use the word concern, but what are the things, if you had to rank things that you really want to get past this milestone, that milestone? What are you looking for tonight when you're on console?
So the first things I look at are the things that Melody is concerned about, weather, right? Because that gets us we can either get into tanking or not. I feel really good about tonight us getting into tanking and getting through that. The only things that we're looking at really during the count is we've had hydrogen leaks, in some of the wet dress rehearsals. We've done our best to mitigate all of the concerns with those, with a lot of changes to the boots and to the lines and to a lot of different things. We've changed some of our evaluation criteria to give us more flexibility on what we can do. So that part gives us a little bit of something that we look at, and that as we go through and that we kind of evaluate. And then the rest of it is just everything else, right? We need to be on time. It's been difficult for a number of reasons as we've run through the wet dress rehearsals to get through all of the work with the constraints. The great thing is we have done an outstanding job addressing each and every one of those things that have caused us concern or delayed us for the reasons that we've had through those countdowns. And so we've got a lot of practice behind us. We've put those things behind us and addressed each and every one. So going into this, I feel like we are in the best possible configuration we could be to get to launch on launch day. So I feel really good about.
All right, we're going to go to 2 on the phone. We have Stephen Clark, Spaceflight Now.
Hi, thank you. Stephen Clark, Spaceflight Now. What are, if any, the weather constraints for proceeding into cryogenic tanking tonight?
The constraints for tanking tonight are mostly a temperature constraint that we wouldn't even approach it because it's very cold. And also we have to have less than a 20% chance of lightning to tank. And that's a determination that my tanking LO Mark Berger would make tonight.
Thank you, Stephen. We also have Arik Malek, space.com on the phone.
Yes, hello. This is Arik Malek with space.com. And I think my question is for Jeff. This is the first flight of a new rocket. I'm just wondering if there's anything special you're planning to tell the team before you really get into the final phase of the countdown, or a little commemoration. How do you plan to kick things off tonight?
This is it will be a special day tomorrow. It is every day really for Artemis as we've been able to get into the launch countdown. Our team has been excited for a really long time about what they're doing and what the way in which they're supporting this program and our ability to get back to the moon and put people on the moon. And so I wait to work with a lot of folks that are a lot younger than me these days. I've been around for a while. And to see their faces and to hear their voices and the excitement that they have each and every day. Because we ask a lot of folks, as a lot of the programs do, to get us to this point. And they've done an outstanding job. We'll talk to them a little bit. I know when I come on console, I'm going to walk around the firing room and talk to folks a little bit and share some of our stories that we can before we get on console and we get into the terminal part without disrupting them obviously too much from what they're doing. I would expect that we'll probably have some words towards the end as we're getting ready for the poll or coming out of that as well. So there might be some words there, but I don't have to do anything to get this team motivated or to get them prepared. They have done an outstanding job getting themselves in that position, and we're ready to go.
Here in the front row.
Great. Thank you. Ken Kramer, Space Up Close. Thanks for doing all this. My question is for Jeff. Going back to the lightning protection system. So this was a moderate weak strike. What if it had been strong, like the really strongest strike that this could withstand? Would you have had enough time to evaluate the system, or would that have caused a delay? And I'm also wondering if you're thinking about any upgrades to the lightning protection system after this launch. Thanks.
So the lightning evaluation process, if we meet our threshold criteria, involves certain levels of retest. We have a panel that makes recommendations on that based on the criteria that's been developed, and then those come forward to management. Some of those take quite a bit of time. We can get the times for you. It would have been a challenge. We may not have had to do all of them, and it's very dependent upon the size, the magnitude, and all the other things that we've seen on our triggers. That's what we may or may not have had to do. So it's really difficult to say whether there would have been a delay. Clearly, the system worked as designed, and so that the process is to do evaluation, gather the data, make a concerted effort to make a decision.
Did you know that if you were born after 2000, during your entire life, there has been someone living in space? That's thanks to the International Space Station, which celebrated its 20th anniversary of continuous human habitation in 2020. You've probably heard a lot about the incredible science that happens on board the station, but the outside is actually prime real estate for all kinds of experiments and technology development too.
The International Space Station is a great platform to demonstrate service and technology because it provides power, data, there's robotics in space.
Hi, I'm Jim Seymour from NASATech.net, and I have a question about commercial and military aircraft that might be in the air about the time of the launch. So I assume that there's some sort of requirement for
With Tech on Deck, we'll be talking about some key experiments that have taken place outside in the harsh environment of space, which will help us advance human exploration.
I also wondered whether any
Next is NASA's Exploration and In-Space Services Project Division, the Goddard Space Flight Center. The goal of the division is to usher in a new era of more sustainable, affordable, and resilient space flight, both near the Earth around the moon and deep
So
in
we
the
do work
solar
with the
system.
FAA.
Many members of the Nexus
Right,
team
there's
started off with the
during the
Hubble
times of launch,
telescope servicing missions.
No different than
We've
any
taken
other
that technology, applied that to robotic servicing.
has to do
From robotic
launches
refueling
as well.
missions that will help
So that
spacecraft
happens,
live longer
we've been
and journey
working with them for
farther
an
to
extended
autonomous
period of time.
navigation systems, NASA's
military,
Exploration
etc.,
and
all
Space
we have,
Services Division has taken
noticed
advantage of the
airmen,
wonderful
looking for all
opportunities
types of
station
aircraft that
offers
may or
to
may not
test
be
new
there. So
technologies.
we work very closely
As we
with them.
look to
do the same
exploring
thing
our
for the
solar
waters as
system
well.
and beyond, and establishing a sustained human
Probably won't
presence
go
in
into what
space
the-
beyond
the
low Earth orbit,
spaces and those
many of these
are,
technologies will play a key role.
Security posture,
We use the robots
but
and
we do
space
have all of those
stations to
things lined
demonstrate
up.
the technologies needed to enable satellite servicing in the future. We've also used the robots and space stations to do some of the more repetitive tasks or the dangerous tasks that astronauts shouldn't be doing, like going outside the space station to try to look for ammonia leaks. Robots are very good at moving fine, delicate positions, moving back and forth. Doing those sorts of tasks would be challenging for humans to do.
In order to live in space, astronauts will first need to reach their far-out destinations like Mars. This will require refueling and replenishment of oxygen supplies, things the robotic refueling missions work to demonstrate on station.
Specifically,
They will
for
also need to
people
be
who
able to
aren't at the
construct,
Cape, how
maintain,
far
and
can
repair their
we
habitats,
anticipate
as well as
people
adapt
can
to unforeseen
see
circumstances.
Artemis lifting off? For
Because
example,
we're in space and
will
low
our
orbit, we have
listeners
lighting
and readers
conditions
and viewers
representative
in Gainesville be able to see a
objects in
fireball?
space. And so allows us
give
to
me some
launch
sort of sense of
tools
how
and
far
modules
across
into
the
orbit, put them on the space station, and then use those robotic
I'm not
technologies
sure
and all the
exactly.
infrastructure that comes with the space station
But I will say,
to mature those
we'll
technologies
see more of a
in a way
fireball
that's
with
much,
this
much
one
less
than we would
expensive than if
see
we try to
with
launch
any
our
of
own
the
satellite and
recent launches that
demonstrate
we've
those
had,
for the first time,
shuttle
not using a
very
space
far
station.
away. It is a
For these
daytime launch,
endeavors,
not a
Nexus
nighttime
has
launch,
worked
and
with
of course
astronaut
at
tools,
night,
satellite
the
servicing, and
travels a little bit
on-orbit
farther,
assembly and manufacturing will do the
so,
trick.
We develop the
I think you'll
technologies
probably
that are
be able to
needed
see
to advance
it from there.
exploration
I have
in
friends
ways
in
you
Tampa
can
that
service
usually
satellites in the future, build
something
satellites and
general.
build
So with
structures
this,
on orbit,
I think you have a better shot.
refuel satellites on the way to other planets, repair
Hi,
those satellites
Jacob
much like we
Sedesi,
do on
also
that
from
the space station.
WDFT
Both
News.
humans and robots
So
are used to
obviously you all
maintain
been talking about
habitats
all
in
these
space.
pre-flight
We're developing
preparations that have
technologies
been
that
going
can be
on
used by
in
NASA
this
and
last
others
countdown to
to
launch.
make those a reality.
How different is
The
that
International
process
Space
going to
Station
be
is the
when there are
perfect
actually
testing
people
ground
on
for
board?
technologies
Is
that
this
will be
process
used
that you're
to
going through right now
propel
going to be
farther
pretty
than
similar
we've
to
ever
what it's
gone
going to be
before.
like when the
The
craft is
station is
actually
helping
manned?
us build the
Or
necessary foundation
is
to
it
make
going
it
to be a little
possible.
bit different? Is it a little bit looser than it would be?
Outside of the International Space Station,
So,
space
the
can be a
difference
lonely
is,
place.
will
Most
primarily
satellites
be
are
related
designed to
to
live their
crew
lives alone,
activities.
and we've yet to
As
find
they're
life outside of
coming out.
Earth.
The
This
process
means that
for
when we
preparing
launch a
the pad
spacecraft
for
or
launch
satellite,
is the same.
for the most
Process
part,
for
it's on its
preparing the
own,
vehicle for launch is the
and has a
same.
limited lifespan based on when
Loading of the
critical items like
cryogenics will
fuel
all
run
be the
out
same from that
or
perspective. The only
break.
difference, which
You
is
wouldn't throw away
related
your
to the
car if it ran out of
is the
gas,
fact that we will
and
have
thanks
a
to
new
the advent
sphere,
of modern-day
a larger
robotics,
sphere for
software,
the
and
next launch
computing
because
power,
there's more
we will
capability
soon be able to apply that logic to satellites.
to allow us to have more. That's different, so we will have a little bit different loading process. Not sure if that's going to extend or not. The crew time will add about 2 hours is our estimate at this point because we don't have the crew yet and all
We are on the cusp of breaking the one-and-done paradigm that exists for most satellites.
It's about 2
An
additional
important
hours
step in
of
that
countdown.
direction is NASA's
Maybe we
Robotic
start
Refueling Mission,
earlier,
or
like 2
RRM,
hours or so,
demonstration
based on
on
what
the
we're
International Space Station. Because
I'm gonna go to
refueling
one
a
on the
satellite
phone
that was
that I
not
am
designed to
tracking
be
through the
refueled has
room.
never
The
been
phone
done
is
before.
Marvin Marshall.
Practice is key.
The
With that in
nighttime
mind, the
is
first two
space
phases of RRM took place on station from
Hi, my name
2011
is
to
Marvin Marshall.
2017
I attend you
and tested
space
the
report
tools,
here on
technologies,
Twitch.tv.
and techniques to
I
refuel
appreciate
and
you guys
repair
taking my
satellites
questions.
in
My
orbit.
questions for Melody. At what time, Eastern time, will you be pretty certain, to call and go on launch today for those, couple primary weather constraints that you're worried about? Thank you.
We're wanting to use the robot on the International Space
It's
Station
really going to
be
depend
able
on
to
the evolution of the shower coverage offshore.
So we built
I think around 5 a.m. will be a pivotal time because we'll
Consisting
really
of
see
a
what we're
module
dealing
or
with
box
usually around
affixed
that
to
time
the
frame.
outside of
We see the
station and
max of
robotic
the
tools.
offshore
The
land
demonstrations
breezes
use
colliding.
station's Dexter robot to operate
We'll be able
tools
to
and test
see what kind
servicing
of showers
tasks
we already
such as
have out
cutting
there,
and
and we'll be
peeling
able
back
to track
protective thermal blankets, unscrewing
moving
caps,
towards
turning
Space
valves,
Coast.
transferring fluid,
Of
inspection,
course, if we
and
push later into the
necessary steps
window,
leading
we'll
up to
have to adjust
refueling.
that time frame a little bit.
Once
But
we
5
were
a.m.
all
will
done,
probably
we
be
were
a
able to
pivotal time for
transfer
us.
fuel end to end
Thank you, Mark.
through a spacecraft fill and drain valve that wasn't designed to be robotically refueled.
The RRM demonstration helps test and prove technologies that will make refueling satellites not designed to be refueled possible, something that will be further demonstrated by NASA's on-orbit servicing, assembly, and manufacturing mission. But it also helps lay the groundwork for designing future satellites in a way to make them more easily serviceable.
These missions were important because we needed to demonstrate in orbit that this technology was ready. There were a lot of people that felt that
right now we
at
don't
the time of
have
RRM,
launch
the technology was so far in the future that they didn't feel what we were talking about was
30th,
possible.
31st.
So we needed to
So our next
demonstrate
opportunity
in
would be the
orbit
second.
this technology so that we could start changing the paradigm and incorporate these technologies into future spacecraft design.
Maybe a question for Megan.
RRM Phase
tell us,
1 and
where
2
the Vice
were all
President
about
will be
preparing an
watching the
interface
launch
for
from, and
refueling,
you expect
which in
her
many
to
ways
speak to the
is
team
half
after
the battle.
in the firing room.
To robotically
Have a
refuel a
successful
satellite, you need to perform a series of highly dexterous tasks to even access the valve.
Watching from nearby
The next step is to actually perform refueling tasks, which is what the next phase, RRM3, has been demonstrating on station over a series of operations since 2018. RRM is a critical piece of the sustainable spaceflight puzzle that helps us with the ability to robotically refuel, repair, and maintain satellites in both near and distant orbits,
First of all, I think for Jeff,
well beyond the reach
this is a
of where
test flight,
humans can go
obviously.
today.
Are there different weather constraints for this mission than you would have down the line? You're going to be able to sort of close the windows of constraints on launch as you sort of get more experience flying the system. And then maybe for Melody, talking about those launch windows later on where you get in the afternoon, evening, and you get those slower storms. Like if you were launching today at 12:48,
First and foremost,
tomorrow
fuel.
12:40 instead of 8.
This is not only true for getting to Mars,
with the confidence
but for any form of deep space exploration. Being able to replenish fuel on a long-duration journey means massive amounts aren't needed up front, freeing up space for other important things.
Our launch
Enter Robotic Refueling Mission 3, or RRM3 for short. This demonstration launched to the International Space Station in December of 2018 and has helped us develop tools and techniques needed to replenish cryogenic fluid in space.
Yeah, that is correct. I think mostly our weather constraints will be the same. The one thing that would not be included in the POV, the probability of violation, that we would just also be tracking is maybe just watching
Transferring
more recovery
cryogenic
weather,
fluids has never been done before in
in
space.
case the astronauts
These
need
super
to-
cold fluids
for
can
some
be
support
used as
or anything like
propellants,
that.
coolants, or for life
Could
support
you repeat the
systems.
second part of your
Being able to
timing of
replenish
the
these
day?
fluids that run out,
Yeah, I think
otherwise
40
known
to
as
50,
consumables,
for
is an
probably
important
a
part of the
conservative
sustainable
40 to 60
exploration
would
roadmap.
probably be, a
Not
good
just for
estimate
Mars,
during
but
that
for
time
NASA's
frame,
Artemis
especially with this
program,
weak
which
flow
will
that
land
we
the
have.
first woman and the next man on the moon.
We've seen a lot of showers pop up
Since
during that
refueling
time frame, but they
cryogenic
don't
fluids in
move
space has
very
never been done
fast.
before,
Of course,
RRM3
that's due
tested
to
the
the weak
technologies
flow.
and
So
techniques
it really depends on
needed to make that
exactly
possible.
where the showers are
First,
forming.
we sent
and
the
it's really not
RRM3
also
payload
just
and
about
its
showers,
three
it's
main
about
tools
how
to space
tall the
station,
clouds
where
are before
astronauts
they
assembled the
produce
parts.
the precipitation.
When I was living aboard the International Space Station in the spring of 2019, I was fortunate enough to take part in the very small part in the robotic refueling mission 3. And my job was to unload the components of the actual RRM3 from one of our visiting vehicles, and we take it into our Japanese experimental module, the GEM, where we have an airlock. And right inside of the airlock, we unpacked all of the boxes, much like you would a piece of furniture that you had to assemble yourself at home. So unpacked all of the pieces, we did a checkout, we worked with the ground, we got everything assembled, and then we placed it into the Japanese airlock.
We have a
and
lot,
from there we were able to put it outside of the International Space
pretty much
Station.
everything
So
you listed.
my involvement in RRM3
we
was
have our
the physical
radar. We also
final
have,
assembly
we also
of the actual
other service Melbourne's backup radar.
RRM3 was delivered to the space station by a SpaceX Dragon on the company's 16th commercial resupply services mission and installed on the outside of station by the Canadian robot Dexter. Dexter then picked up the tools from the JEM airlock and installed them onto the RRM3 payload.
to different things.
The ground operations team was now
but
ready
yes,
to begin
we're also
operating
sending
3
up
tools
balloons.
to test how they
We
would
also
work in
have
space.
something called T-drip.
For the first set of
and,
operations,
we also have the
conducted
915
in August
megahertz radars that are
2019,
sensing
Dexter
the
used
low-level,
one of the
boundary
RM3
movement
tools
of the
to
winds.
prepare the RM3
We
module's
have
interface
a
for
NASA
transferring
supplied
cryogenic
jet
fuel.
that we can
The
fly
second
out
set
to
of
any
operations
concerning
was then
clouds,
conducted in
to
October
see exactly what
2020.
the cloud edges are.
For these, Dexter used one of the remaining 2 tools to insert an 11-foot-long
and we also
hose
have a
in an
Merlin
open port,
lightning
and the
system
other
that
snake-like
we
camera
use
inspection
to
tools
track any
simultaneously
cloud
to verify the
ground
hose's
lightning,
position in the
that is
inside of
occurring. So we
RM3's
have
tubing.
all the tools.
This
to
marks
watch
the
that
first
kind of
time that Dexter
situation.
had tools in
And,
both
could you remind me of
arms
the
working
second
the
part of
same
your
tasks simultaneously.
Yes.
The RM3 demonstration
I'd
added
have to look at
experience
it
and information
specifically, but
to
I
NASA's
believe
knowledge
that
base
even
on the
though
storage
a
and
lot of those
transferring
showers and
cryogenic
thunderstorms
fluids in
are
space.
lingering along, I think
It is currently
farther
still on
away
station where it will
than
conduct
10
one final
miles
set of
from
operations
the
in
flight path.
mid-2022.
So I think we would be
For
okay.
getting
Of
to the
course, I don't
moon,
have
Mars, and
radar
beyond,
specifically
cryogenic fluids will be
right
used
now,
as
but I think
propellants
we'd be fine.
and to maintain
The-
life support
the good
systems
news
for astronauts.
is a lot of these showers
The Mars
at night
atmosphere
follow
is made up of
warm
carbon
waters of the
dioxide,
Gulf Stream,
which could be
and
converted
exactly
to
where
liquid
Pod
oxygen,
39B
a
is,
type of
it's kind in
cryogenic
that
fluid
sheltered
that can be
area
used both
cooler
as
waters.
propellant
Of course,
and
we
for
are in
breathing.
summer, so a lot of the waters are
Astronauts
warm
may be
anyway,
able to
but
fuel
it is
rockets or
a little
replenish
bit
their
of a
oxygen
shelter for the
supplies
pad.
using compounds found in the Martian atmosphere.
That corner?
A tool on
Hi,
the
Lauren
Mars
Brushes,
Perseverance
Bloomberg.
rover
I'm wondering
called
if you
Mars
could clarify
Oxygen
further this
Institute
blackout
Resource
dates you were talking
Utilization
about.
Experiment,
I believe
or
yesterday
MOXIE,
Charlie said there
is
were
set to
other
demonstrate the
opportunities
first
to launch
ever conversion
that weren't
of
just
Martian
the second.
carbon dioxide
Perhaps we
to oxygen,
misunderstood.
which
Some
is
of us
another
thought that
important
maybe there
piece
was
of
an
the puzzle.
option to launch during those blackout
In
dates.
order to make
You
a
just confirmed that
sustained
you
human
cannot
presence
launch
in space a
on those
reality,
dates if we don't launch
humans
on
and
that day.
robots will have to work
Right
together
now, yeah.
using technologies like those
8:29
developed by
tomorrow is our first
RM3
opportunity.
and
The next one
MOXIE.
after that's the
A
second.
lot of people ask about
Between the
that.
second and the fifth,
Whose job
are
is
opportunities
exploring outer space? Is it
available,
robots
which I
or
think Charlie was
humans?
alluding to.
And I believe
for
that
example, if we did not
it requires
for
teamwork
example,
between robots and
on the
humans,
second, for
and
some reason,
that our exploration is not
potentially,
complete or even
we could potentially
possible
come back
without
the next
both.
day and try again, because that is a
So,
day. If in fact we got the
Robots
range and all
can
the
go
other things lined
farther.
up for us,
They're less expensive.
So there are
And
other days. If we take,
they can go
however,
for longer periods of time. They don't
we have
require
to
as much
take
maintenance. You don't have to
replenish
feed
the
and care for a robot, much like
and
you
that
do
doesn't
if
get
we
us
send me
to
back to
the next
space.
day.
So,
that's-
like the Mars
there's a lot
rovers,
to
the
unpack and all
Galileo
of that,
that
but that
explored
would
Jupiter and its
then push to
moons,
the fifth,
the Hubble,
because we
and
have to
soon to be
replenish
James Webb
and
Space
replenish our
Telescope.
hydrogen.
They are doing missions in locations that humans, to this point, don't have the capability to go. There's also something very important about humans wanting to know what it's like to be there.
Is that,
it's not enough for humans to take a picture of Mount Everest or Antarctica and say, "Oh, okay, that's what it looks like." The human condition is we are born to explore. We're born to say what if, what's just beyond what we know,
So
and what is it like to be there.
Okay.
And so
And
the
if
human
we-
side of space exploration, first of all, it's orders of magnitude closer to Earth. We have not been able to send humans nearly as far as we've been able to send robotic probes. But they're two very different
And
missions, and they
if for
serve
some
a
reason
different
the
type of
engines
curiosity.
ignite and then abort.
Mars
right?
and deep space are calling human explorers,
You have to replace those
and RM3
engines
is a step toward helping NASA answer that call.
Obviously, roll back to the
Though
pad
it
to
sounds
do that
complex,
or not.
the idea is
and
simple.
What kind of a hit would
Having
that
the
take?
ability to refuel will allow NASA to
whatever you
embark
need to
on
do
longer
to
journeys
get
to
back for
explore
your
the
next
depths of our solar
Yeah,
system.
and the plan is to, if in fact there were the case where we had an engine shut down, we would do the normal operations to get off the pad.
Did you
come
know
back to
there's
the,
a three-eyed
to
raven
the VAB.
currently
We would be
perched on
looking
the
to change out
International
those
Space
engines. That's the
Station?
quickest path.
Not an actual bird,
to
but
get us
rather a
back to
technology
flight.
payload that
And
is helping NASA
the actual
develop a
amount of
relative
days,
navigation system, or
I don't want to
autopilot,
give
for
an
spacecraft.
actual number. I
Launched
know
to
we have
station
that,
in
so I think we can know
2017
that.
aboard a
So, yeah, we
SpaceX
can get that
Dragon
number.
on the company's
I just
10th
don't have
commercial
it
resupply
exactly.
services mission for NASA,
Yes.
installed on the outside of
And then
ISS
also we
by
have to look
station's
at that and
Dexter
where we line up
robot.
with our launch
Raven
periods,
is equipped
because
with
we don't
3
have all
distinct
days
camera
in the
vision
months
systems,
ahead. So
visible,
there's a lot
infrared,
of things
and
that would
LiDAR.
have to be evaluated once we
Combined Designed with NASA-developed software algorithms, this rotating module technology keeps a weather eye on Orion spacecraft.
Talk to the events about launch opportunities on the 3rd, the 1st, and 4th, and the 6th. Any topping again?
So we have available
Raven's head,
days that we
containing
would
its
have
3 eyes,
from a
or
vehicle
cameras,
perspective and
is
mission
always on the
performance
swivel,
perspective
which is
that
made
we
possible
launch,
by
and
its
those are the
integral
dates that you
gimbal.
just alluded to.
Raven is an
The range is
on-orbit
always,
test bed that
has
was
to be
built to
negotiated
mature technologies
just
related
because
to
customers can
relative
run off
navigation
very
sensors
quickly,
and
as we
algorithms.
see,
Raven was launched to the International Space
so we would have
Station
to have that
aboard a
conversation
SpaceX Dragon capsule in February 2017.
I don't have
And it's been operational on the space station since that time. So using 3 different sensors on Raven that are on a movable gimbal platform, Raven can track the incoming visiting vehicle to station all the way from very, very far away, all the way up to where they dock with the space station. So basically, at any given time, Raven can tell you where the incoming visiting vehicle is in space relative to the space station and what attitude or point
in the launch firing we have about
Raven sends the data it collects from tracking and observing incoming spacecraft to
in
its
shuttle we had over
processor or
200
brain, called Space
in the
Cube.
launch team. So
This
it's quite a
information then tells
different
Raven how it
size
needs to
team.
move to continue to track the
The firing
spacecraft
layout
and
is
gauge
different than
relative
it was in
distance
shuttle.
and
We
position.
did that
NASA engineers have
coming
taken
into
what
this
they've
program,
learned
so
from
it is a
multiple
little
Raven
bit different,
observations
and
over the years
it actually
to
is
adjust
a little
and
more
fine-tune
conducive
the
to
relative
the way in which
navigation
we do
system
the work,
as
so that
needed,
really helps us out.
so it's ready for the
The
upcoming
second part of the question
on-orbit
was
servicing, assembly, and manufacturing one mission, which will robotically refuel a satellite among
how
other
the team is
Raven is a
working,
sensor
what it
system
feels like to be
that
on
can
this team
image an
with
object,
people who've not
process
been through a shuttle
those
launch or
images
what
on board
is
in
very
real
much
time
the
with
same,
advanced algorithms and calculate the
shuttle.
pose of the object relative to itself.
We have a
These
mix, right?
factors
We still
come
have some
together
folks
to
that have
create
been through
something
shuttle,
like spacecraft
not as many as we
autopilot.
used to, quite a
Much like a
less.
self-driving
So
car
that
can
helps to
maintain cruise control based on the
at least
speed
try
of the
to
vehicle it
give some
follows,
guidance to the
two
folks
freight-flying
that are coming up
spacecraft
from
will
an
be able
experience
to
level
dock with
to
one
give them a
another
flavor of
using
what to
this
expect.
technology.
Because
So this operation
haven't
is
been
similar
through
to the
it,
autonomous
and
docking of
they're very
visiting
wide-eyed
spacecraft to station.
doing a
Raven's unique
fantastic job. We have
application
some
is necessary for docking
extremely
two
smart
satellites
people that
with the
have come up
challenges of each
very quickly
moving
through
and
the ranks
rotating in
to
every
get the positions
direction
that they
during the
now
rendezvous
hold in the
and
firing room.
Using that information to then guide
So
the first
that part has been
spacecraft
really
to
good,
autonomously
from a team
rendezvous with and dock
and I
with the
think
second
it's-
spacecraft.
to me
So
it's-
that means
it's
finding it in
different, but
space,
it's a lot of it is the
aligning
same.
with it
The way in which
appropriately,
we
and then
run
bringing the
countdowns
two vehicles together
still
without
is pretty
smashing
much
them
the same way
into
as what we
and
have in the
destroying
past.
each of them.
Our expectations
All
are
without
high.
human
The
intervention.
demand on the team is
This
also high, but
capability is the kind of thing you need
is
for
also
docking with
extremely
spacecraft
high.
that were not originally designed
We
to be
have
docked
trained
with
and
in
trained
service,
to get them to the
which
level
happens to be a vast
so that they would
majority
be
of
ready
them.
to support
That's why
this launch
Raven's
countdown.
time on station
And
is
everybody has to
critical
have a
to the
first
future of
right.
on-orbit
This is the
servicing,
first
assembly,
for
and
a great
manufacturing,
number of
or
people in that
OSAM.
room.
The OSAM-1 mission will
Okay, we
use
have
Raven's
Ken,
relative
and then Eric,
navigation
and then Bill.
capability
Sorry.
to autonomously
Well, thank you. I'd like to follow up to what
rendezvous
you
and
just said
dock
to the
with the
colleague
satellite,
about
and then
ignition
telerobotically
aboard.
refuel it.
You
This will be
said
the
you
first
have
time
to
in
roll
history
back
a
the
spacecraft
rocket,
not originally
have
designed to be
ignition
serviced
aboard, and
will be
swap out
refueled
the
as a
engine.
means to extend its
Why is
operational
that?
life. Raven is
So,
also
just
important for
evaluate.
future
there's
exploration
a number of
missions.
things that happen.
Raven's
And
technologies can be
these engines are
applied
very
to
similar to what
future
we have
NASA missions because if
shuttle,
humans want to make a footprint in the
but there are a lot
solar
of them are
system beyond
inspections
low Earth
and other
orbit,
things that have to
which is
happen
where the International
in
Space
research
Station
and
is
the
located,
themselves.
we're going to have to rely on some form of autonomous docking
We
technology.
may still have
in the
opportunities
future.
to do this.
Whether it be an unmanned cargo vehicle meeting up in orbit
but
around the
we
moon,
go back to do it.
refueling
It actually
tankers
takes less
located in
time.
geosynchronous
We
Earth
have
orbit,
other engines that are
or a
available for
return
other
vehicle
missions
arriving on
to
Mars
swap
in
engines
advance
out,
of
then
crewed
we have to
landing.
go back and
All of these
disassemble them,
feats will require the
and do
technology we're
inspections,
developing
and get them back
Using
to
its three
functional
eyes,
thing through
Raven is
testing
looking
and
for the
put it
moon,
back together
Mars, and
to make sure that
beyond.
we're ready to go.
Relying on highly
Use them again.
robust
So that's
autonomous
the part
systems
that
becomes more
happens.
crucial the further you move
The
away from
reusable
Earth
engines,
as the
but
communications
we do
time
make sure
shortens
there's no
drastically.
issues or other concerns.
Once you move
Just
past
had
low Earth
an
orbit,
engine import for
it's
some
very
reason, right?
impossible for
And so we're
humans
going to
on
go back
Earth
and make sure that
to
we
do these
understand
highly
exactly what
complex
happened.
maneuvers in
And
real
it's not
time.
across all
It's
of
more efficient to allow
allow computers to perform these sequences autonomously without human intervention.
You would just
Although
be able
Raven
to
has successfully
evaluate them
concluded its main mission
and roll
objectives,
back out
it
without
remains on
swapping them.
station. Meanwhile,
So
its
that
team
I
on the
probably
ground
can't
uses
answer
what
that
they've
question
learned to
because I
develop
never
more, never-before-seen technology
answered
that will
absolutes
enable
like I
future
just did.
space exploration.
So I don't think that I think that I would have to say the normal plan. No problem. You don't want to be at the launch pad.
If you need to fix something in space that wasn't designed to be fixed, it's going to take all the experience you can get. With that in mind, when the International Space Station's Alpha Magnetic Spectrometer, or AMS, needed repairs, NASA's Johnson Space Center and Goddard Space Flight Center used their joint expertise to make it happen. At Goddard, that expertise resides in NASA's Exploration and In-Space Services Division, or NEXUS, which evolved from the office that was responsible for the Hubble Space Telescope servicing missions. Key to these missions was the development of specialized tools. While you've probably heard of Hubble, you may not be as familiar with AMS, so let's start there.
We're trying to beat the weather with the work that we have. We do have some constraints as we do in the roll itself, and so we were trying to do that. Plus, we got to get off the head. There's
Designed for a 3-year mission of sifting through cosmic ray particles, AMS has been looking for signs of dark matter from its position on station since 2011. Hundreds of researchers have used the data collected to investigate the source of the mysterious substance to help us better understand the origins of the universe. To continue this important data collection, AMS needed an upgrade due to general wear and tear from the harsh environment of space, specifically a new cooling system. A repair could extend its life beyond what was originally planned. Sounds easy enough, right? In fact, due to the instrument's complexity and the fact that it was not designed to be repaired, even gaining access to the system to replace it was difficult. AMS's design did not incorporate the kinds of interfaces that make spacewalks easier, or have the ability to be serviced with traditional multi-purpose tools. And so, over the course of 4 years, NASA got to work designing and developing some of the most complex spacewalks since the Hubble servicing missions in the 90s and early 2000s to fix AMS.
The AMS tools themselves were unique. They were built specifically for this task, a task that was never intended to be performed on a spacewalk, so that required a lot of thinking about how we were going to get inside so that we could access the tubes that we needed to cut into, and then install the new thermal control system, but also how to put handling aids on it so that we had a place to attach our tethers, to attach our foot restraints, to have handholds, have a place to attach equipment that we needed out there.
NASA developed 20 specialized tools to make the job possible, and on November 15, 2019, astronauts Anna Morgan and Luca Pamitano got to work. On this first spacewalk, astronauts needed to get access. By design, 5 of the tools could be seen floating off into space, attached to the debris shield that was removed to give the astronauts access to the heart of AMS.
The debris shield handling aid was one of the first modules that Luca installed on the EVA, and it gave us a handhold to install the debris shield to work from, but also a handle for me to hold on to ultimately when we jettisoned outside of ISS, which was a lot of fun.
The astronauts continued with 3 more spacewalks over the next 2 months using all specially designed tools.
Stop streaming.
Which was a direct result of multiple practice sessions at the Space Center facility.
You will not be able to reconnect.
While practicing,
your stream will stop, and you will not longer be live.